So another question which is very similar to question number 9, and I assume the same issue that you were facing, is determining the potential difference between the two plates. So here you can see one is in plus 2000 volts, the other is in minus 500 volts. So it is like this. The top plate is in, so let's say the top plate is A and the bottom plate is B. So we can write an equation saying that the potential difference between the plates, that is V is equal to VA minus VB, right? But if you look that is 2000 minus 500. So 2000 minus 500 would be 2500, right? So that's the issue here. So once you are able to calculate that potential difference, then I think the rest is easy. Now again, if of course these things we would study in detail in the next chapter, but this is simple, and again you can look at it conceptually. Now the meaning of this plate is being 500 volts and this plate is being 2000 volts, mean from some common point. Let's say there is a point C. Now in that question number 9, Earth was that common point. Now when you are measuring the potentials, you're going to measure them from the same level, right? From some like the same level. When you say, okay, now go back to question 9. So here we say the top plate is 800 volts and the bottom plate is 300 volts. But with respect to what? That's the question. So the top plate is 800 volts with respect to Earth. That means if a 1 coulomb of charge is going to go from the point Earth to the top plate, then it needs 800 joules. And the same here, you're comparing from Earth. Every voltage is given with respect to Earth. Otherwise, it makes no sense. Now, if you are giving this as 800 volts with respect to Earth, and if you are giving this as 300 volts with respect to some other point in space, it will not make any sense. Then you can't do any comparison logically. But here the Earth is shown in this question number 25. The Earth, or whatever the common source, the reference point, that is not shown. But you can think, if you can visualize this, like the wires come and this is 2000 and then here is the Earth. So if you can imagine like this, again here is Earth. So if you can imagine like this, then okay, let me okay, we have two plates and you have 2000 volts here and you have minus 500 volts. If we try to redraw this setup like the earlier question in number 9, question number 9. So this is like you have a point and this point is like Earth, and this point is at 2000 volts. And here you have the point, and then there's another point which is connected to Earth, and this point is at minus 500 volts. Now what is the meaning of this 2000 volts? When a 1 coulomb charge is going to go from here to here, it needs 2000 joules. What is the meaning of this one? When there is a 1 coulomb charge and if it needs to go from here to here, that means it needs minus 500 joules of energy. What is the meaning of minus 500 joules of energy? You need like the charge gives out like the charge that is not given 500 joules of energy, it gives out 500 joules of energy when it goes from here to here. Now if you look at this, when it goes from here to here, it it needs transfer, it needs 2000 joules of energy. That means when it comes from here to here, then it loses minus 200 joules of energy, right? So when you say it goes from here to here and the potential difference is minus 500, that means when the charge goes from here to here, it doesn't transfer 500 joules. It doesn't it need 500 joules. Some like it can be given 500 joules. Okay, let me say it again. So when a charge, 1 coulomb of charge needs to go from here to here, it needs 2000 joules. So we have to give it 2000 joules. Now this is like the charge would give you back 500 joules when it wants to go from here to here. So what happens here, we give 2000 joules, and when the charge goes here, the charge gives that 2000 joules to something else, like the electric bulb, or if there's a circuit. But here it is like the other way around. It will steal the energy from the electric bulb. I'm just saying as a like how to imagine it, and it would give it back to you. That's the meaning of the minus. So let's take, I have to give someone 2000 rupees, that is plus 2000 rupees. But if someone has to give me 2000 rupees, I can say it as I have to give them minus 2000 rupees. Saying that someone has to give me 2000 rupees is same as saying I have to give them minus 2000 rupees, right? So if you have that, then this is, you can understand 2000 minus 500 minus 500, that would end up being 2500 volts. So then you have the gap, which is 5 centimeters. So that's 5 centimeters, 10 to the power minus 2. That's going to be 500 times 10 to the power 2. So this is your electric field strength. E is equal to V over D, and I have calculated the electric field strength. Now from the electric field strength, you need to find the force. You multiply by the charge, 1.6 times 10 to the power minus 19. So this is going to be now 1.6 times 5, that is 8 or 80. So there's only one answer given in the choices that starts with 8. Of all the choices here, there is only one answer that starts with 8, so I won't worry about the powers. I would just mark it. And 25th, yeah, T.